want to start this video off for applications of counting. The first thing we want to talk about is the idea of probability again and how that works. So the probability of an event equals the number of the events that you're looking for divided by the number in the complete set. So if you look over here, with 26 divided by 52 times 25 divided by 51, let's say I wanted to draw 2 red cards from a deck. So if I wanted to get 2 red cards, if you think about the deck of cards, there are 13 cards in a suit, and there are 13 diamonds, and there are 13 hearts, and they all are red. So that means out of all of the deck, there are 26 red cards. So what we're going to do is we're going to draw a card. We're not going to replace it, and then we're going to draw another card. So when we do that, I want to have, or my choices are 26 red cards divided by 52 in the deck. This is the first card. Assuming that it's successful, and meaning times in statistics, then what we want to do is draw the next card. But the problem is we only have 51 cards left. So there are 25 cards left that are red divided by 51. So what's happened is this is a without replacement. So we drew a card, we didn't replace it, we drew another card. This is what we call a dependent event. And what happens is the occurrence of the first event definitely affects the probability of the second one. So what we want to do is just get started. So between permutations and combinations, we can now do more complex probability problems. And we can do them more easily than we could before. That's referring to Chapter 8. This is especially true without replacement, which is what I described up here with the cards. So what we can do now is start with less complex counting problems as well. So these are less complex than the ones in the following videos. So I have a shipment of 13 computers, and they arrive, and 4 of them have some sort of defect. What is the probability of picking a single computer, that's just one computer, and it doesn't have a defect? This is part 2. So I need the probability that of that shipment of 13, one computer I will pick without a defect. So remember, probabilities, the number of events divided by the number in the set. So we have to use our combination techniques. So we're counting. We have 9 computers. Let's go back up here. We've got 13 computers that arrive. 4 have a defect. That means 9 don't. That means 9 are good. So of the 9 good ones, I'm going to choose 1. Then I'm going to divide that by the total ways I can choose a computer. I have 13 total computers, and again, I'm only choosing 1. So if you use your calculation, and always if you've got this number, your number in your set, and then the number R is 1, it's always going to be this value. So this is 9/13, which is 0.6923. So we've got about a 69.2% chance of picking one computer that has no defect. What's the probability of picking 4 computers and none having a defect? So to change that scenario a little bit, we're picking 4. So I've got this box, and I'm randomly pulling 4 computers. So I need to count the number of ways that I can pull out those 4 computers. This is a combination because order really doesn't matter. So I've got 9 computers that are good. I'm going to choose 4. And then I have 13 computers. And then I'm going to choose 4. So this is the number in the possibilities. This is the number in the set. So let me go ahead and show you how you want to enter this in your calculator. Yes, you can use all your simplification techniques by hand, but I think sometimes this is a little quicker. So we've got 9, go to probability, choose your 2 option, choose 3. Now, what you need to remember is the calculator knows that that means one number. So we're going to divide that by 13, choose 2. Actually, number 2. So we're going to choose 4. And the calculator knows that that is a number. So we have one combination divided by another combination. And when we hit enter, I entered the wrong number, so let's do it again. So I've got 9, 2, we're choosing 4. And then 13, choose 4. Okay, so there we go. And then converting that to a decimal, this is what it looks like. We're changing calculators. So I'm going to enter the 9. I'm going to enter the 9. Probability, I want to arrow over to the combination, hit enter, hit your 4, divided by your 13, combination, enter that, and hit your 4 there, and you get the exact same value. So that's using your technology. If you've got a Casio, you're going to have to find that button. It may even be a second function. A lot of calculators will put that combination business in here. You may find it under a stat button. You may find it under a math button. Really would be easy to Google. Okay, let's do the next one. You pay to play a random raffle ticket contest. There are 10 $50 prizes, 15 $20 prizes, 25 $10 prizes, and 50 losing tickets. Means you draw a ticket and you get nothing. What is the probability of picking 3 $50 prizes on your 3 picks? Okay, so I'm going to pick a ticket. That ticket doesn't go back in. I pick another ticket, pick another ticket. So that is a combination. Okay, so we're looking for the probability that my 3 tickets will be a $50 prize. So that means I've got 10 $50 prizes. I'm going to choose 3 of those. And then I need to divide that by the total number of tickets. Well, if you add the 10, the 15, the 25, and the 50, you'll get 100. And then you're still choosing 3. So here, I went ahead and calculated this one and did the division, which is totally acceptable. You can also use your calculator to get that done. So what you'll notice is that probability, that decimal is really far from 1, so it's not very likely. If you convert that to a percent, then you've got about 74 thousandths of a percent chance of that happening, which is not very likely.